Institute of Engineering and Management, Kolkata, I extend a warm and enthusiastic welcome to all distinguished speakers, respected faculty members, industry experts, research scholars, and participants to day 3 of the ATAL sponsored faculty development program on demystifying data for intelligent applications in real world scenario. The past 2 days have been immensely enriching with exceptional insights from both academia and industry. We have explored cutting edge developments in artificial intelligence, machine learning, big data analytics, and real world application that are shaping the future of intelligent systems. The active participation and thoughtful interaction from all of you have truly elevated the learning environment of this FDP. Today, we begin day 3. We look forward to another exciting set of sessions that will further deepen our understanding and data driven technologies. We are honored to have with us eminent experts who will guide us through advanced concepts, practical applications, and emerging trends that are redefining innovation across sectors. I am confident that today's discussion will not only broaden our technical perspective but also inspire new ideas for research, teaching, and real life problem solving. I encourage all the participants to stay engaged, ask questions, share observations, and make the most of this platform for collaborative learning. Once again, a very warm welcome to everyone. Let us begin day 3 with the same enthusiasm and curiosity that has defined this FDP so far. Today's first speaker is Mr. Mrityunjoy Sen. He will be taking his second session today. Mr. Mrityunjoy Sen has been in the IT industry for 2.5 decades. Presently, he is associated with LTI Mindtree as Director, Digital Engineering Practice. Prior to LTI Mindtree, he worked with Cognizant, IBM, and Infosys and played multiple roles in different capacities. He is very passionate in learning and building solutions in the field of artificial intelligence and machine learning. So I will ask Mr. Mrityunjoy Sen to start his session. Thank you, sir.
Thank you, sir, and a very good evening to all my respected faculty members. So today's session is basically a continuation, going to be a continuation of where we left yesterday. So before I proceed, let me share my screen. Can anyone please confirm whether my screen is visible?
Yes, sir, your screen is visible.
Okay. Thank you, sir. Let me bring up the PPT. Okay, so yesterday we discussed about what is machine learning. We also talked about what are the different types of machine learning that we use. We primarily focused on supervised learning, and under that specifically we talked about regression model, and we also tried with one regression model, basically, which is going to predict the CO2 emission provided we have attributes like number of cylinders, fuel consumptions, and other parameters available. Right now, if you recall, we discussed about regression, and we use regression algorithm when we predict something which is numerical and can have any values. Any continuous numerical values is going to be the output. On contrary to that, now when you are supposed to predict something which is not numeric, which can be numeric and cannot be numeric, but which is of type categorical in nature. What I mean by saying categorical, the output is a discrete values, a categories. Like if you are to predict something in yes or no, right? Whether a mail is a spam or not, whether today rain will happen or not, it will rain or not. So these are binary classification. So the thing that you are going to predict are of two types. Similarly, you can say whether the person is going to, based on his academic records, is going to pass or fail. It may not be only binary classification, it can be multi-class classification also. Sometimes like you are going to predict something which can be of like, good, very good, bad, something like that. So these are all the
Sir,
value that you are going to
sir,
predict.
sorry to interrupt you.
Yeah.
Have you shared any screen?
Yes,
Means your
yes.
PPT, your PPT is not visible.
Oh, is it?
Yes, your
Let
screen
me.
is visible, but your PPT is not yet shared.
How about now?
No, yes, now it is shared.
Okay.
I
Okay.
think it will be better if you go
Yeah,
to
I
the
will.
slideshow
Yeah,
mode.
I'll go to slideshow mode. Okay.
Yes, yes.
Okay.
Okay,
So
thank you, sir.
I'll go there. Make it
Okay,
slideshow.
sure, sure, sure.
So basically, we talked about regression primarily of two types: simple regress linear. We showed one example, ran the code with simple linear regression, where we considered only the one attribute as input, and then we tried to predict the CO2 emission. So that is a simple linear regression. Then we considered other two attributes as well, because actually CO2 emission is influenced by multiple attributes, and we ignored some of the important attributes. That's why the result, the prediction accuracy was pretty low. And when we went ahead with multiple linear regression, considering all the attributes, we got a very good accuracy, right? So that was the linear regression. And then today, what, as I said, we are going to discuss about the other type of common type of supervised learning, which is classification. Okay. And as I said, we use classification when we are to predict something which is in categorical in nature, right? It can be 0, 1, it can be 1 to 10, any integer value. It can be, anything like yes, no, anything. So I will show you one example. Things will be clearer to you. Now, for classification, the most common algorithm that we use, very easy to understand algorithm, is KNN, K nearest neighbor. I will discuss in detail, right? So this is a most common type of classification algorithm, KNN, and it categorizes the samples element based on its similarity. Means, so all similar samples will be classified into one category based on its attributes, right? So we will discuss that in detail. Now, this is the data set that I will be using. So if you see on the screen that here I have few records of few students. Okay. So the first row, if you look at, Karuna, and I am considering the aptitude and communication skill. So aptitude skill, if you look at for Karuna, is 2 in a scale of 1 to 10, and communication score on communication is 5. So that means his communication is good but weak in aptitude. So those who are good in communication and not that strong in aptitude, they are classified as speaker. That's what you see. Karuna, then Bhuvna also, like, her score is low in aptitude, but communication it is 5 or more. So she is also classified as speaker. Similarly, we have few students who are good, only good in aptitude, but communication aspect a little weak. So they are intelligent, but communication is not good. So they are classified as intel. Okay. And similarly, there are few students who are good in both aptitude as well as communication. And those people are classified as leaders, right? If you take an example, Dinesh, the 5th row, if you see, his score is in aptitude is 8 and communication is also 6. So he's a leader. So basically what we see here is there are 3 type of students. Some of them are speakers, some of them are intelligent guy, some are leaders. Okay, so this is what the data set that we have. So what we will do, so we will use this data set and train the machine to classify whether a person, given the aptitude test score and communication skill is provided, then system should, from this data, system should learn and then should be in a position to predict whether the person is going to be a speaker, is a intel, or is a leader. Okay, so that is the thing that we are going to achieve. So this is the problem statement. You have some data of few students, their aptitude and communication skill, and you also providing what type of students they are, speaker, intel, or leader. So that's why your data set is labeled. Class output here is the class. So that is provided. So it's a supervised learning. So why supervised? We are helping computer system to learn from this data, where we are telling if aptitude score is this, communication skill is this, then it is the class will be that, something like that. So from this data, system will understand how to classify a student whose new student whose aptitude and communication skill were not known previously. But if you try to check whether machine is able to predict or not, based on the learning on this data, machine should be able to predict if the training is successful. Now, how? So we generally, as I said, there are different machine learning algorithms are available for training for the classification kind of a problem, but KNN is a very simple one, and we will discuss just to give you a feel how it works, and then we will talk about other available classification algorithms, and then we will do some coding. And if after that, if time permits, so we will also talk about unsupervised learning, one type of unsupervised, that is clustering. Okay. Now, how KNN works? So here, as I said, similar objects will have the similar attributes. Like if you, as I was showing you, like all animals will have some common attributes. Fruits, all fruits will have some common attributes. Trees will have some common attributes, right? So they will be, if we consider the attributes, they will be in the similar group, similar region, same regions. All trees will be in one region. fruits will be in one region, something like that. Here, if you see on the screen, you see some blue dots, right? So they are all similar in nature, and that's why they have been colored as blue, and we are calling it class A. They are all under class A. And orange dots you see, they are having different set of attributes, but they are similar in nature, and they have been classified as class B. So generally what we see, if we plot their attributes, we will see all similar objects will be in one region, and the other type of attributes, objects of similar nature, they will be appearing in one specific region. Okay, so that's what. Now if I give you, so this we were having some samples of class A and some sample of class B. How KNN works? Now if we give you a new object which is unknown to you, whether that will be in class A or class B, how will you classify? Here in this case you see a star, black star, right, on the right hand side graph. So this, just seeing the position of the star, we are not sure whether it should be classified as class A or class B. So then how we will classify it? We will see whether the star, who is the nearest object from class A and class B, who is the more nearest to the new object, that's black star. And if the blue dot is having one blue dot is the most nearest one, then the star will be classified as class A. But if we see the star is more nearer to is anyone asking any question? Otherwise, can you go on mute, please? Okay, thank you. So if we see that the black star is nearer to orange, more nearer to the orange dot, then that black star, the new object, will be classified as class B object. Okay, so KNN checks the new sample is nearer to which class, right? Now the problem with one sample is, now it may be the black star may be nearer to blue one, but that blue one sometimes may be classified wrongly. So if you just check only one sample nearer to which one object, then you may not get the right result all the time. Okay. Now what we will do, if we consider, instead of one nearest object, if we consider, just a second. Now you see here it looks like it is nearer to both, similar distance, right? So if we calculate the distance and see it is the same distance, then it is very confusing, right? Now instead of 1, if we see, take, okay, k equal to 3, the KNN, k is an integer number, k can be 1, k can be 2, 3, 4, 5, any value, integer value. K represent how many nearest object you will consider to decide the class of the new sample. Here in this case, we assumed that if we assume k equal to 1, then the problem is there may be one object from class A and one object from class B having equidistant from the new sample. So then in that case, it is going to be very difficult to decide which class this new sample black star will belong to. So to avoid such situation, what we do, we will consider k equal, if we consider k equal to 3, that means will check the distance of all the objects and see which objects, which are the 3 objects nearer to the new sample. And out of the 3 objects, we will take a vote. So who belongs to which class? In this scenario, you see, we see one object which is in class A, but the 2 other objects are from class B. So the sample, new sample black star will be classified as class B object. So it is basically decided based on the distance. And when we calculate the distance, we use the Euclidean distance, okay, not the Manhattan distance. But there are use cases where we need to use Manhattan distance as well. Okay. Now we will, the data set that I showed, we will calculate the values and things will be more clear to you. Now sometimes what happens, k equal to 3, lower value of k does not give a right prediction. So we take a higher value of k, and if you take a very high value of k, then also we will have a problem, right? Assume that here, if you look at, if we select k equal to 6, then you are considering the 6 nearest object. Even though x is very closer to amber objects, amber dots, orange dots, but when we consider k equal to 6, here we are seeing that the 4 of blue dots are nearer to, out of the 6, 4 blue dots are basically 4 dots are from class A and 2 are from class B. So if we do a voting, X will be classified as class A. But actually, X is more closer to the amber of the dots, so that's why it should be ideally classified as class B. So for KNN, it is very important that whatever value we decide for K, that should be an optimal value. Okay, it should not be very high, it should not be very low. So what value of K we should consider, I will show you. It should be generally what we take based on our experience. So if you have say 100 samples, basically square root of 100, which is 10, generally square root of n number of samples is the right K value to consider. Okay, so this is how the value is classified. Things will be more clear if I go to this example, right? So this is the data that we will calculate, we will consider for our calculation. So out of these records, this is the training data. For training purpose we will use, and then our objective is to test with which group the JOS will belong to. We know that JOS is an intel. Considering that aptitude and communication skill, it is an intel. But we will see whether the system is also going to predict JOS as intel or something else, right? So how we will do that? So now this is the data. What we will do? We will plot this data into a graph. Things will be clear. Now, x-axis we will plot aptitude, y-axis we will plot communication. So first is Karuna. Those who are speaker, those rows I have highlighted in amber, orange color. Leaders have been marked with blue, and the intels are in green. Okay. Now first one is Karuna. Aptitude 2, communication 5 is a speaker. So now you see the dots coming in on the graph. Bhuvna, aptitude 2, communication 6 is also a speaker, amber. Third one, Gaurav, aptitude 7, communication 6, leader. Similarly, next is Parul, then Dinesh, then Johnny, then Bobby, Porimal, Govind, Sushant, Gauri, Bharat, and Ravi, and Pradeep, right? So if you see, you are you noticing that all the speakers, they are in one region, and then all the intel, they are in another region, and the leaders are in different region. Now if we will predict what is the class for Josh, right? That is what our intention is. So how that happens? So what we will do, and this is the Josh. Josh is represented as a red star. This one, this is Josh. So we will calculate the distance from all the points. We'll calculate the distance of all the students from Josh and see who all are the nearest one, and based on k value we will see in which class Josh will belong to, whether Josh is a speaker, Josh is a leader, or Josh is an intel. Okay, now how do we calculate? So we, as I said, will use Euclidean distance. Now if you look at Karuna, aptitude to communication skill is 5. So we know it is a speaker, and what is the distance? Josh is having 5 and communication 4.5. So we will calculate the distance, like 5 minus, so you know how to calculate Euclidean distance, x1 minus x2 square plus y1 minus y2 square, and then square root of whole thing, right? So here, if we calculate the distance between Josh and Karuna, it is going to be 5 minus 2 whole square, basically 3 square 9, and then 4.5 minus 5, that means minus 0.5 square, meaning 0.25, and then that means 9.25 and square root of that. So if we do that, the distance that is coming 3.041. So the distance between Josh and Karuna is 3.041. Similarly, we calculate what is the distance between Josh and Bhuvna, distance between Josh and Parimal, distance between Josh and Jani, distance between Josh and Bobby. So we calculate all the distances between Josh and individual other students, right? And then we have, now if we do a sorting, here you will see, if I consider k equal to 1, that means what? We will consider only one person, one student who is having nearer to Josh, who is only one student who is nearer to Josh. So here, if I see the data, I see 1.118. This is the lowest distance. So Gauri is nearer to Josh. Okay. So if you set k equal to 1, and Gauri belongs to, Gauri is what? Intel, right? So if Gauri is Intel, then, and if your algorithm you use in KNN, if you use k equal to 1, then Josh will be classified as Intel. Okay. Now if you take k equal to 2, then we will consider the two students who are nearer to Josh. So one is definitely Gauri. Then who is the next nearest person? 1.414. This guy, Sushant. But here, if you see, the problem is Gauri belongs to Intel category, but Sushant is a leader. So if we do a voting, it's 1:1. It's a draw. So we are confused. We cannot take any decision. So that is the problem we can face if we have k value equal to any even number. So then if we take k equal to 3, then what will happen? See, so we know Gauri, then next is Sushant, then who is the next nearest person? That is the Bobby, 1.5. Distance is 1.5. So now you see Bobby is Intel, Gauri is Intel, and Sushant is leader. So which class Josh will be classified as? Josh will be classified as, out of the three, two are from two are Intel, so JOS will be classified. Majority of them are Intel, so JOS will be classified as Intel. So this is how KNN model works. Okay, so I will show you some code how actually this KNN model works, or if we are to solve this problem programmatically using Python scikit-learn model, how that will work. So I will show that the code part, and then we will directly go to the Google Colab, like what we did yesterday, and then we'll run. You will see, and you will get a much better feel of it. Okay, but this KNN is not used. KNN is not used widely. The reason being, KNN is very easy to understand, right? The way I explained you, most of you probably have understood it and got how it works. But is it effective? The answer is no. It has many cons than pros. Okay. KNN is considered as a very lazy learning algorithm, and there is no learning at all. Okay, so in industry or even in your educational purposes also, KNN is not used anymore. It was earlier days, it was, I mean, it was a very common model when other classification algorithms were not there. Now we have much better classification algorithms like random forest for binary logistic regression, then support vector machine, naive So there are many decision tree. So there are many other good classification algorithms available nowadays. So we don't use KNN. So another reason why KNN is called a lazy learner. If you yesterday when we discussed about the regression, machine learned from the data. It was a real learning because machine came out with that equation which represents the relationship between input and output. And when you give any new sample, machine will put that value into that equation and calculate the output. So it was so the outcome of the learning was that equation which represents the relationship between input and output. So basically the input output function, that actually was the learning outcome. But here, if you for KNN, machine actually has not learned anything. So during training, it just memorized everything, all the samples and their values. It memorized the data. And when you are actually trying to predict, that time only it is doing everything. It is calculating the distance of all the samples from the test point, and then decide calculating like who all are nearest ones, and then checking who are the nearest whatever samples who are nearer to the test one, what in which class they belong to, and based on k value it is basically predicting the in which class the new sample should be classified to. So everything is happening in the runtime, but there was as such no learning so called. So per se learning, there is nothing. So that's why it is called lazy learning, and mostly it is not used much. Okay. And another problem is, say the example that I took, it had only two input attributes, that is aptitude and communication. But in real life, and also we had very few number of records, only 15 16 I believe records that we consider. But in reality what happens is, you will have lakhs and some millions of records, number one. Number two, each record will have, can have 100 200 attributes. Now if you have 100 200 attributes, calculating the distance x1 minus x2, y1 minus y2, z1 minus z2, similarly 100 attributes, and then we do a square and then take a square root for each sample, and then you have 10 lakh samples. So for, you have to calculate the distance of those many people. So the computation is very large. It will consume a lot of resources, and result wise also everything is happening on the runtime. So performance definitely is going to be a question. So that's why KNN is not used. Rather, we used other models like SVN, Nebus, then logistic regression, random forest. So those are the models that are commonly used. Okay. Now, this is just to the, my intention was to give you a feel how classification works, how computer classifies it. So KNN is very easy to understand, and next other models you can go back and do a little bit of study. You will understand. They are also not very difficult. You can understand quickly. But if we are to solve this problem, what are the different steps? First, as I said, first step is to mount the data. If your data is in a drive, your Google Drive, then you need to mount that Google Drive. Second, you need to read your CSV file, which is your input data set. And third, you visualize the data through scatter plot, and then see how the data is kind of, whatever the graph that I showed, you can get, whatever classification machine will do, you will be able to correlate. Then you split the data into, like all other machine learning problems, you need to split the data into training set and test set. You can do it 80-20, 75-25, even 70-30 also. Then you identify the predictors. Here we used KNN models, and then we once we predict the data, then we evaluate the, when you do the testing, you then evaluate the performance of the model by checking the accuracy. Okay. And finally you can display the confusion matrix. So I'm not going in detail what the confusion matrix, we will show you. If you see the output of the code, you will get to know how, what is it, and get a better feel. Okay. So code wise, the steps that I mentioned, 7-8 steps. So first is mounting the Google. I have that code. Second is reading the importing the important library functions, then reading the file into data set, data frame, Python data frame, and then you visualize the data. Here also, like if you see, what I showed, people who are having low aptitude and high in communication, they are called as speaker. Then there are people who score are high on aptitude but low on communication, so they are intel. And then these are the guys whose score are good in both, so these are the leaders. Okay. So let's see whether, when if we do it through Python code, whether we are getting the same result or not. Okay. So let me. Okay, so now you see my file is present in my drive, then machine learning folder. Under that I have a folder called KNN classification. So in that folder there are two files, KNN dataset version 1.0, then KNN dataset version 2.0. So I am using 1.0. So I will show you the code. You will be able to see it there. Okay, connection lost. We reconnect it. Okay. Now you see that what I am doing, I'm first mounting my drive, because my CSV file, the dataset is present in this folder in the Google Drive. So I will run that first. Okay, so it is mounted. Next is, now I have imported whatever libraries that I need, like yesterday, and you see here my drive, then machine learning. Under that I have a KNN classification folder, and there if you look at, the file name is KNN dataset 1.0.csv. Right, so KNN dataset version 1.0, this is the file I am using. So if I read this file, you will see this is the, so it has 15 records, okay, and 3 columns. What are those 3 columns? Communication, aptitude, communication, and class, which is the output. So then, just to visualize the data, what you can do, okay, aptitude versus communication, if you plot, so you see there are 3 regions. Okay, so this is one region for which we have low aptitude but communication is good. Then there is this region, if you are able to follow my cursor, this region which is aptitude is good but low in communication, and then the other region here, which is the set of people who are leaders, whose aptitude and both communication are good, right? Then next, if we run this code, that here only actually we are using that machine learning part, scikit-learn model. So what model we are saying, this is, here we are splitting the data set. So scikit-learn provides the function model selection. If you select this one, training test split, so it will help you to split the data set. Okay, so predictors is basically my first 2 rows, that is aptitude and communication, that is my input. Target is the 3rd column, which is the class. Okay, and then I am splitting it into training and test. So if you see, test size is my 20%, that means training is the remaining ones, which is 80%. Okay, and if I print the data, you can see, right? So here what we see is, so we have around 15 records, right? 15 out of 15 records, so 20% of 15 is 3 records, right? So you see these 3 are used, Parul, Parimal, and Ravi. So these samples are used for testing, these 3, and these remaining 12, which is 80%, these are used for training purposes. Okay, and for we have the corresponding Bobby, Intel. So there, what is the class of individual, all of these students. So Parul, we know, is Intel, Parimal speaker, and Ravi Intel. So now we will only give machine that test data, these 12, for learning, and then we'll ask machine to predict what is going to be the class for Parul, Parimal, and Ravi. Okay, so this is what is we are doing here. So if you see, the function that we used, classifier that we used is the K neighbors classifier. In scikit-learn, this is the classifier that we use. You see only 3 lines of code. It will do the classification. So basically here we are, this is actually the training things is happening here. Okay. So what it did is test set prediction. What it predicted? Intel speaker Intel. So these three, Parul Intel, Porimal speaker, and Ravi also Intel. So you see whatever is there actually based on the 12 records, it actually predicted the remaining three, and it predicted absolutely right. Okay, and if I am to evaluate, so that evaluation happens through confusion matrix. So you need to study a little bit, and the Python, if you know little bit of Python, you will be able to do this coding. Now accuracy 1 means 100%. Okay, 2 Intel, this is called true positive. It is, they are actually Intel, and system also predicted Intel, so these two right. And this is one is true negative, actually one is speaker, and system also predicted as speaker, so these are right. So if you see this uh, table, see what is given means actual and what was the prediction. Parul is actually an Intel, system also predicted Intel. So this is a good learning, but this is a very simple, visually we can see, but that's not a very complex one. If you are to solve a complex problem, then your number of attributes will increase. You need to provide a lot more data, not even few hundreds. You actually need to provide 30,000-40,000 records at a minimum to have the computer predict rightly. Okay. And recently I have solved one problem for my organization, very interesting problem. I will share, and then probably we can switch to the unsupervised learning. I think we have some time also in hand. So the problem was uh, beginning of last year, 2023, around April, May timeframe, in our organization, a lot of people were kind of putting in papers. They were leaving organization, and our HR observed that there are few good set of people who actually stayed with us for quite some time, but still they left, right? So definitely they were not happy, but they decided, is there any way we can stop people exiting our organization? So then after a lot of deliberation, what came out was the final conclusion was, what has happened. We cannot do anything with that. But is there any way we can get a sense who all are the next set of people who potentially might quit in the coming days, right? So can we identify those set of people so that we can take proactive measures to talk, and then HR can talk to them. Proactive measure means HR can talk to them, then identify whether they are really happy with the organization, with the work, with the salary, with the benefits they are enjoying, or they have any concern, right? So that was the idea, and with that, but problem was how that problem can be solved. Getting early sense of people who might leave is not an easy task. So that problem statement came to some of us, and we decided that why not machine learning model we should use, and try to predict. At least we can give it a try. We should. So we discussed with HR, and we told them that, you give us some past data, right? People in our organization who have already left and the people who are still continuing, and we need all the attributes: their current salary, how long they have been with the organization, what is their designation, uh, where do they stay, their native place and where they are posted. So, and when their last promotion happened, what was the salary hike. So they provided all the details. Okay, and then we process that data, and then finally, actually we did that. The data that they shared, initially the data had very few, it was a biased data set. uh, they provided, I think, around details of around 5,000 people, but out of the 5,000, only 100 or 150 resignation cases were there. So that is not a good thing. So we said, at least, we need more detail people of who exited us, so more such cases. But they provided few more, but eventually we created some synthetic data to balance the data set, like 50-50, people who are still continuing and then people who left. So we created some synthetic data, and then we identified, out of 5,000 people who are with us in a particular group, we identified around 410 people who potentially can leave. As per machine learning model predicted around 410 such cases. And we shared that who are those guys. You won't believe, it is a very difficult, and within 4-5 months, so after sharing that result, what HR observed that, around 113 or 14 people actually left the organization. So initially they did not have any confidence on this prediction. So, but after 3-4 months, when they saw that, actually this data set cannot be, I mean, the result cannot be ignored, they are seeing that within 3-4 months itself, and they, after that, few more people also quit the organization. So that was one problem we solved, and it was a binary classification, whether they will quit or not. So that was an interesting problem. So you might get similar such real life problems, which probably you can try to solve through classification. Okay. So with that, I will pause here. Do you want to, have a question answer session on classification now, or you want me to continue with the unsupervised learning, clustering, and then at the end we will have the question answer session?
Sir, there are two questions.
Yeah.
One has been asked by Navneet Kaur. She's asking that how categorical variables are handled in KNN.
Okay. So here in machine learning, I did not tell you one thing. It's a very good question. If you look at the data set, no, then all the data is numerical. Okay. The data that you see, or maybe I can show you, but machine learning, the machine understands only the, sorry, if I go little back, the data that I had here, all are number. The aptitude, communication is a number, but here class is a categorical value. It's a text. So whenever you have text, so there are scikit-learn provides methods to convert it into numbers. Okay. So anything which is in text, that should be converted into numbers if it is part of input figure features. Okay, so you can use some one hot encoding, you can use other functions, but there are many. You can use them, and any text should be like here speaker, Intel and leader. So this is a text, but this number should be converted into, so speaker is can be 0, Intel can be 1, leader can be 2. So any number when we feed into any model, it should not be in text. It has to be a number because machine understands only number. Okay. Any other question?
Uh, yes, sir. There is another question asked by Ajiteshmay Ghosh. Sir, what can be the best way to count k?
Sorry, or is the best way to count k? Okay, okay.
Yes, yes, yes.
So generally, as I said, there are two ways. Uh, you whatever code I ran, same thing. The evaluation you can try to solve your problem with k equal to, say, you can start with k equal to 3 and then see what is the accuracy. Then k equal to 4, what is the accuracy? So people, what some of the people, machine learning developers, what they do, they try to plot, they run the same model with different k values and then see where the accuracy is, they are getting a higher accuracy value and they stick to that. But generally, in general, what we have seen, it is advisable that you keep your k value which is equal to square root of n. If you have in your data set, if you have n number of samples records, then as I explained you, if k value is say, if you have 100 records, then you can set k as nearer to 10. So that is one another way of seeing. But if you plot it, then also you can see sometimes square root of n may not give you the right accuracy, but it is better you run a for loop with different k values and then see where you are getting uh, maximum accuracy, and you can stick to that.
Okay, sir. There is another question asked by Shuchita Tripathi. What number of data do we need for a training model?
What number of data? I think Shuchita is trying to say, the question is how many record samples for the training purposes. See, generally, the example that I showed, it had only 15 records, right? And that too, okay. So that too, 12, used for training and then 3 for testing. Generally, even for a kid will not, go ahead with this, many number of records. Uh, at least to get a good sense, I would, depending on the complexity of the problem statement that you are trying to solve, I mean, minimum, I would suggest, 10,000, 15,000 records you take. If it is not a very simple problem, the one which I showed, that is does not even require machine learning. Anybody can visually, plot the data and tell you. So that is just for, training or for the purpose of showing you how it works. But it on actually in real life, these many records will not fetch you any satisfactory result. So I would suggest, somewhere around at least, few 10,000, 12,000 minimum. That's what my gut feel is. or my experiences.
Uh, Sir, Debashish Chakraborty has said that categorical attributes will lead to misclassification if we use KNN.
Absolutely, absolutely. Generally, that's what I used. That we should not be using KNN. KNN is not a very good model. Okay, uh, at least use SVN, random forest. You know, if it is a binary classification, logistic regressions, naive bias. So those are the model you should try.
Okay, sir, no more questions yet.
Okay. Okay, so we'll now, so far then we have covered supervised learning. Uh, Basically the two common types, regression and classification. But the one thing that you might have observed, the dataset we used for both the cases, it had both the input and the output. In yesterday's regression file, we also mentioned if your engine size is this, your fuel efficiency is this, then CO2 emission. So while we were training, we were also having in the sample data, training data, we had the output also. Now, and for classification today also you have seen, like, along with the aptitude communication, we are also providing, if this is the input, then this is your output. That is your what is the class, Intel or uh, Intel or speaker or leaders, right? But uh, in case of unsupervised learning, as the learning name suggests, unsupervised, right? So there is no supervision provided for the learning. So here the output is not there. I will show you will understand that, okay, how it works. I do not have the code ready since I requested. So today I prepared a couple of slides to explain you how uh, this clustering happens. So we will use k-means, the most simple one. Hmm. Let me show the PPT. Okay. So basically what we will cover is what is clustering is one type of unsupervised learning. There are many other things, but this is one very commonly used unsupervised learning. So we'll talk about that. What is it? Then what are the different types of clustering methods? What is one algorithm, statistical algorithm is k-means. So we will discuss how it works. And then we will see what is the pros, cons, and we'll see, we'll show you how it is being calculated. So hands-on probably we will skip. The time will also not permit, I believe. Okay. So let me move to slideshow mode. Now here, if you are given, as this image you have seen yesterday also. So here what happens is you have some set of objects and you need to cluster them. So the difference between classification and clustering is, in case of classification, you know the sample, what type of sample it is. Like I said, okay, this student is a leader, this student is a speaker, these are the students who are Intel. But here you will not be given any, there won't be any output. Data is not labeled. Okay, which sample is what, that information will not be provided. If you see in this image, if you have few birds, you have few uh, animals like dogs, cats, and all, and then there are some fishes. Okay, so you don't know which is what, but some species, some animals are there. So with that, what you can do, you can only, if you are to do something, you can at the best, what you can do is you can classify, you can cluster or group the similar species together, right? So when you do that, you group the object based on their similarity. This is called, similar objects can be clubbed together and can be clubbed in one group. That is something you can do, right? So here, if you look at, these are the, in this is my not data which is not labeled, and through unsupervised learning we can say, okay, these are one type of objects or animals, this is another type of, this is the another type, based on their similarity. Okay, now how it happens we will discuss. And when we see like how we, what is the similarity here also, when we use k means, we actually calculate the distance, we calculate the Euclidean distance. Okay, distance using, and each attributes as the, based on the values of the input parameters, we see what is the distance between them. And if the two objects are similar, the distance between them will be very less, so they will fall under one group. So similar objects will fall in one group, so intra-cluster distances are will be very less. So two objects in one group, one cluster, will, the distance will be very less, but the objects between two different clusters, they will have a distance will be maximum, but distance between two objects in same cluster will be minimum. Okay, so this is the concept that we will use for clustering. So there are primarily, three types of clustering that we can do. One is partitioned clustering. Like if you see, we can, this is the sample. So we here, if you look at, these are the samples. We have clustered them into 4 groups. This is one group, the partition by this, like this is one area, this region. You can partition maybe in terms of geometry. So you can consider this as cluster 3, say, quadrant 1, quadrant 2, quadrant 3. So here X and Y both are low, right? In this, let me use. So for this cluster, both X value and Y value are low. And this cluster, X is high, but Y value is low. This cluster, X value is low, but Y value is high. Here, X and Y both are high. Okay, so you can do the clustering through partitioning. Then what is the other one is hierarchical. Like you can cluster, if you think of an organization. So you have say executive management, right? Under them mid management. So then comes the junior developers. If I talk about my own organization, we have software engineers, senior software engineers. Then they will be reporting to some architect or tech lead. Then so hierarchy wise, they will be reporting to, then architect leads will be reporting to project manager. Then project manager will be reporting to senior project manager. Then so you can cluster things based on the designation. So developers are one cluster. So then project managers are one clusters. Then executive managers management is another cluster. So another clustering approach is the hierarchical clustering. And then another thing is like based on the density. It is based not based on the uh, region, but based on the density. If you look at this data here, if we plot the samples, we see there are samples which are accumulated here in this region. Here the density is high. Here also there is a density high, and then in between there is a space where we do not have any samples or low density. So that's how where you have a high density, you can consider that as one cluster. So similarly here in this sample we see 3 clusters. Now in this example you can see there is one area where the samples are distributed, so density is very high, and then there is a center where also we have a high, and in between you see in this white zone there is not much samples available. So that's why it is segregating into 2 samples, and then this is another area where the data is spread. So we can consider this as another cluster. So clustering is done through either through partitioning or through hierarchy or through density. Okay. Partitioning cluster, k-means. So, okay, we will discuss about the k-means. Let's see how much time we have. Okay, so I will move a little fast. So now we'll talk about k-means clustering, how it actually works. Okay, very interesting. So k means here k signifies the number of clusters. So you have some samples and you need to cluster them. Here you need to decide first how many clusters you want to distribute your samples into, how many clusters. You want to distribute them in 2 clusters or 3 clusters or 4 clusters. That is something in k means you need to tell the system that you want to distribute your samples into 4 different classes or 4 different clusters or groups. Okay, and then it will be then system will actually cluster them as per the number of cluster you have specified. So step 1, choose the number of clusters, which is nothing but the value of k. Okay, so here you can choose cluster equal to 2, or you can choose cluster equal to, so if you choose cluster equal to 2, then this can be one cluster and this can be another cluster. If you choose cluster equal to 6, then this can be one cluster, can be second cluster, this will be third cluster, and then this is fourth, this one may be fifth, this one may be sixth, right? So this you need to tell how many clusters you want. So that is exactly what. So if you select 2 clusters, then it is going to be like this. If it is 6 clusters, then you see these 3, which is represented as this. This way it can system will classify. Okay. So this is a 4 cluster. So in case of 4 cluster, this is considered as one cluster, and then this is second cluster, this is third cluster, and this one is the fourth cluster. But how it works, that is something we will discuss. So assume that your data is spread like this. Okay, and then so you can see that there are 4 different area where the samples are basically spread across, and the center of this, you have some x value, you have some y value. So you can find out what is the center of this. That center is called centroid. Mean of this is on x1 plus y, x1 plus x2 plus x3 plus x4 plus x5 divided by number of samples. So that will calculate the center point, which is centroid. So all these clusters will have one centroid. Okay, now Second step is choosing the initial cluster center. So we need to randomly identify one point as your center in each of these cluster, and then you will calculate whether these points, like if I do this, so you have to select, you have selected k equal to 4. Now then you have to one sample you have to consider as your center, and then you need to calculate the distance of all the points from that center, okay, from all of these centers. Like if I give you one example, you will understand. So this is for this cluster, this is the center. For this cluster, this is the center. So you have four centers, four centroids, okay. Now each and every element you see in different clusters, distance will be calculated, okay. So this point, if you see this point, what is the distance of this point from this center? What is the distance of this point from this center? What is the distance of the same point from this center and this center? Then which will see for this particular point which center is nearer, right? And this, if it is found that now in this case we see for this point this center is nearer, okay. But it may be a situation like this one, this point, okay. This point, if you consider this point, the distance from this center may be higher than distance from this center. So in that case, in the next iteration, this particular sample will belong to this cluster. It will not be here, okay. So based on this, and then again samples will be realigned, and again based on that your centroid will be calculated, and then your centroid can shift to this position. So these steps will keep on happening, this iteration will keep on happening till we see that all the samples are properly clustered. So I will give you one example, so you will see. This is not, let's take an, okay, assume this is your, you have 7 samples, okay, and the values are 1 1, x value 1, y value 1, here 1.5 comma 2, y value 2, 3 4 5 7, like this. So if I see, I assume that I want to cluster these two into two groups, okay. And one, this point is the, as I said, the, to start with you need to select one sample as your centroid. So you select 1 1 is one centroid, and for the second cluster 5 7 is your, that you can randomly select anything. 5.57, sample 4 is your the centroid for the second cluster, right? Now, then what we will do, we will calculate the distance of all the points from C1 and C2. So this is your C1, 1 1 is your C1. So that's why the distance of this point from this point itself will be 0. But distance between of this point and this point is C2. So distance from C1, so this is your C1 and this is your C2. So we are calculating this observation once, first sample itself is a C1. So that's why the distance C1 is going to be 0. But distance of this point from here is 7.21. Similarly, second point, we are calculating the distance of this point from here and from here. So this from C1 is 1.12 and distance is from C2 is 6.16. So that way we have calculated the distance of all the points from center 1 and center 2. Now you see this one center, is there anyone where the center 1 is for first 2 points? Okay, let me go to this. Now you see what, if you look at the first 3 points, we considered that you see C1 is smaller than C2. And third point also, for third point, C1 and C2 both are equal. And from sample number 4 onward, we see that C2 is smaller than C1. So these points you can keep, first 3 points you can keep in cluster 1, and remaining 4 samples you can keep in cluster 2. Now you need to calculate what is the centroid. Now, if these are the 3 samples which is in your cluster 1, then centroid, how centroid will be calculated? 3 plus 1.5 plus 1, meaning 3 plus 1, 4, 4 plus 1.5 is 5.5. So 5.5 by 3 is 1.83. Similarly, 4 plus 2 plus 1, 7. 7 by 3 is 2.3. So centroid has now changed. Okay. So your centroid for cluster 1 is now, earlier which was 1,1, now it is 1.83, 2.33. And for cluster 2, centroid earlier was 5,7. With the realignment, you see your centroid had shifted from 5,7 to 4.13. Now with the new centroid, we are again calculating the distance. And here we see for these 2 samples, the C1 distance of these points from C1, centroid 1, is smaller than centroid 2. So actually these 2 will be in one cluster and remaining 5 will be in another cluster. So you see 1 point has moved from cluster 1 to cluster 2. And then again I am checking with the new realignment. Earlier it was 3 in cluster 1 and 4 in cluster 2. Now 1 point has shifted from cluster 1 to cluster 2. So we are recalculating the centroid. Now we are seeing that centroid for cluster 1 is 1.25, 5.0. How it is calculated? Only 2 points. 1 plus 1.5 by 2. 2.5 by 2 is 1.25. Here 1 plus 2, 3 by 2 is 1.5. And so similarly, we have calculated for these 5 points, we calculated the centroid. Now what we see, we again checking the distance from the new centroid of all the points. So we see that these 2 points are having C1 less than C2, and for the remaining, C2 is smaller than C1. So there is no movement of samples happen from one cluster to another cluster. So when you see there is no further movement of samples happening from one cluster to another cluster, then you can stop the process. So that way, these 2 samples, first 2 samples will be in one cluster, remaining 5 will be in the second cluster. So this is how k-means clustering works. Okay. So with that, I will, and another thing here, you see, k, what is the value of k that we should select, right? Generally. So the value of k is calculated through sum of square error, right? So we calculate the square error through this, like we calculate the distance for all of these points from the distance between the centroid and the points, and then we check like in which value of k the SSE is lowest, and we call it as elbow method. Like if you plot this number of clusters versus SSE value, you will see initially if we have very low value of k, you will see high error, and then as you keep on increasing the cluster number k value, you will see the error is decreasing significantly. And then again after that, even if you increase the cluster, your error will not reduce significantly. It will be more of a static value. So there you can fix the k value. So this is how it is done. So with that, I think we have only 2 minutes. I will take a pause and I'll stop sharing. If you have any question, please feel free.
Participants, if you have any question, please ask.
Thank you, Tanima ma'am.
Participants, if you have any question, you can unmute yourself and can ask.
Yes, someone,
Yeah,
Sujita madam is asking whether, yeah, presentation we will share with sir. Sir in turn will share with you all.
yes, we will share the presentation.
Sir?
Yes,
Am I audible?
Yeah,
yes,
yeah,
you are
please.
audible. You
Yeah,
are audible.
sir. Earlier you were mentioning that you have used some synthetic data generation for your model, right?
Yes.
So okay. I mean, know like which model you have used? Is it like a GAN or something like that?
And no.
Can you pour some
Sorry.
information on that?
Yeah. So I did it 2020 around April May time frame. Exactly, I forgot the model. It's a very common model. Maybe I will share with sir. I don't able to remember. I have it in my office laptop. It's not that we create synthetic data very frequently, but in situation when we have imbalanced data set, in such situation, is the I need to check. Maybe if I can remember in between, I will type it in the chat window. Synthetic, it is. I don't remember exactly. I'll tell you. Otherwise, I will pass
sometime
you
later, like sometime earlier, I was using the STGANs to produce stable synthetic data. So I thought like you were working
Oh,
on
no,
that.
it is definitely not. It was a different model. I forgot the name. Just give me a second, huh? While
No issues, sir.
let me, if I can quickly check, I will tell you. I'm
Okay.
trying to next 1-2 minutes. If I can open my laptop, I will tell you. Just that is also a very common model. I just give me a second. I will tell you. If you have any other question, meanwhile, please feel free.
Good evening, sir. Am I audible, sir?
Yes,
Yes,
you
you are audible.
Sir, may I ask, sir?
Yeah, please.
Sir, my question is related with the value of the K. We have already gone through the K means and KNN. Sir, in case of suppose sample is not balanced, in that case, how can we solve the problem? If suppose value of K, whatever described by you, if we will take the under root of n number of samples, and suppose one category is data set is binary classification related problem. If suppose samples of one category is very more and very less, suppose 20% and 80% samples belongs to category B, and A is only 20%, then how can we justify the under root of n?
Absolutely,
For the
very
value
good.
of A, sir?
Yeah, very good question. See, first of all, for any classification, if you have an imbalanced data set, it is very difficult. Okay, it is very difficult. So try, if possible, try to create synthetic data and try to make the data set balanced. Number one. But you may be in a situation where you are restricted to create synthetic data uh, that may not serve your purpose. You have to go with whatever actual data that you have. Okay. Now, in such cases, you need to, that's what I said, even though I said that you use for k means, sorry, for knn, use square root of n, that value may be, if that value is quite high, you may not get right prediction. So that's why what I said, this is a thumb rule. Thumb rule says you go ahead with square root of n, but that is not that may not give you right result for your specific problem. So what generally people do, they plot the data, right? So they run a loop for k, what is my accuracy, total accuracy I am getting. For k of 2, k, you can, 1 is not used, that is for sure. 2 is also not, k value 2 is also not used. At least you start with k equal to 3. And then say if you have hundreds samples, so thumb rule says square root of n, which means 10. So, but don't go by 10. You do for your particular, the data set that you have, maybe for that data, k value of 5 or 6 may give you the right result. So what you should do, you start run the same model multiple times for different values of k. Start with k equal to 3 and then go k equal to 12, 13. So thumb rule says square root of n, which is square root of 100 equal to 10. So you start earlier than 10, which is 3, and you see what is, start tracking your accuracy till say 12, 13 or 15. Okay. And then you see in which k value you are getting a highest accuracy, and you can stick to that. So if you are getting highest accuracy at value 5 or k value equal to 6, then you stick to that value. So it also depends on the type of data that you have.
Yes, sir. Yes. Sir, my last question is related with the similarity decision of the new sample. It belongs to which category, A or B, on the basis of distance. So you have already described there are two approaches. One approach Euclidean distance and another is Manhattan distance. On basis of which we will decide new sample will belong to which category. Sir, in which cases we will use the Euclidean distance and in which cases we will use the Manhattan distance? In general, you have said generally we use Euclidean distance. Then in which case we will use the Manhattan distance on the basis of data whatever be available?
Okay. I will tell you. Say if you want to travel from your house to office or college, okay, so what you do, you follow the road, right? You follow the road. When you are traveling on road, wherever we have road, we cannot take our car out of the road, right? So there, yes, you have to use Euclidean distance. So you Euclidean have a fixed path. But now, yes, from Kolkata to Bangalore, if you travel through air, yes, if you travel on air flight, right? So there is the shortest distance is basically will give you the, you need to consider the distance as from your point to your source to destination. There is no road as such. It will take the most shortest path. So when you are trying to solve any problems where you can calculate the distance that you are traversing is the shortest route, then you use Manhattan. And if you are trying to solve a problem where you're following a road, right, which you cannot deviate, even if that road is not the shortest route, following the shortest route, but in such cases it is going to be Euclidean distance.
Yes, thank you, sir. Thank you, sir.
Sorry, I told it other way around. So if you are following the road, then it is a Manhattan distance. But if it is a on air, it is the shortest distance, which is Euclidean
Yes, sir.
distance.
Stated. Yes.
Yeah.
Yes, sir. Okay. Thank you, sir. Got it, sir.
Okay.
Sir, there is another question from Ajiteshmoy Ghosh. What is the difference between k-means and k-means plus plus?
K-means plus plus. I have not. In fact, k-means also we don't use. So I don't have any idea k-mean plus plus. Is there anything they have introduced? I don't know. I need to check. Is there anything k-means plus plus? I am hearing it for the first time, but I need to check. In fact, k-means also is something which we don't use much, and it is not recommended. Again, since it calculates the distance and consumes a lot of resources, so this is not a recommended model. But it gives us a good understanding how things work. That's why when we start explaining with k-means.
There is another question from Suchita Tripathi. Why don't we use k-means?
Why? Okay, k-means, again, as I said, since it is related to whenever we are calculating the distance, no, for any problem that we are trying to solve by calculating the distance between the attributes, as I said, say your samples are having 100 attributes, right? Attributes x1, y, x2, x3, x4, x5, x6. And you have y value y1, y2, y3, y100, right? So if you have similar such thousand or lakhs of records, so can you think of the calculations that you need to do to check the distance? Say, square root of x1 minus x2 square plus y1, x1 minus x2, y1 minus y2, z1 minus z2, so and so and so. You have to do that 100 such times, and then that is for one single sample, and you have to calculate for all such samples, right? So this, and then you have to do a square root. So computation time and the resources that it will consume is huge. That is one thing. Whenever there is a involvement of calculating the distance, it is better. And if you have a large data set with lot of attributes, this is not recommended. And again, k-means, again, another thing is k-means is something where the system is not learning at all. It's a lazy learning process. Okay, so it is just memorizing the data, and when you are asking it to predict, that time only, during your prediction time, it is doing a lot of calculations. That is number one, runtime. And since it is, then again, it is calculating the distance. If your data set has huge number of records, and then each record is having, say, 100, 200, 300 attributes, then you are gone. Okay, so you have to wait a long to get your output. So performance wise, it is going to be very pathetic.
Sir, there is another question. What is the difference between k-means and k-midoids?
K-means is a process. And k-midoids, I don't know. Midoid is basically the center point. Centroids, whether they are talk about the same thing, I don't know.
Sir, last question. We will take the last question. This is from Senthil Kumar. How to segregate the clusters?
how to segregate the clusters. See, initially that is what we did. First, you should have something. Okay, I will consider my data to be segregated in 3-4 clusters. Okay. Example, if I give you, now you have a set of students. Okay. And you have their performance data, the results, all of these details are available. So you can cluster them in kind of, based on their performance, you can cluster them in 2 different categories. Like it could be good, I think those who are doing good, and one bad. So probably if your requirement is such that you just know who is good or bad, if you just want to segregate them, that is, then you can go ahead with k value as 2. But it may be the case, like, your situation is such that you want who all are really good, who all are really bad, and who all are doing average. In that case, you are basically going to classify and cluster them into 3 different categories. That is one way of looking at things. Similarly, other way, like, as the example that I gave, the samples that you have, you also need to do little bit of data analysis, which I did not talk about because of the time constraint. So you should also have, when you are solving a problem, basically your everything is with the data, and your data, you have to look at your data set and see what are the different high level categories are there, right? If I talk about, you have the data of, say, fruits, and then trees, then some, four-legged animals. So when you see the data, you will see that broadly I see 3 types of data. So you can classify them 3. Again, what I showed you, the data for the classification, even though it was a classification, but if I only give you the communication and the aptitude data, if I don't give that class, then also how many combination can happen with aptitude and your communication? There can be 4 different combinations, right? So good in aptitude, good in communication, good in both, that is one category. Bad in both, that is another category. Good in aptitude but bad in communication, that is another category. Bad in communication but good in aptitude, that is 4th category. So you need to look at the data and then apply your common sense that, how many possible clusters can be formed or we should form. And sometimes your requirement, the problem that you are trying to solve, that will also drive you what should be the k values for clustering.
Thank you very much, sir. Thank you.
Thank you, sir.
Thank you, sir.
I still
Thank you.
thinking,
Thank you very much for your enriching and enlightening session. It is always engaging and interesting hearing you. So I thank you on behalf of the whole organizing team. I thank you for your support, for your time, and good night. Have a good day.
Yeah, thank you too, sir, for giving me opportunity to present and interact with such a brilliant minds that you have in your organization.
Thank you, sir.
Thank you.